Well, we're going to try it again. Okay, we're getting started here in our first section. A couple definitions to go over here, some terminology to get used to. Quick review: an angle consists of two rays in a plane with a common endpoint, or two line segments with a common endpoint. Measuring angles in a clockwise direction results in a negative angle, and measuring angles in a counterclockwise direction will result in a positive angle. So this will be something probably somewhat new to us. Over here to this side, I'm going to sketch in an XY coordinate plane. The bulk of our work here in Trig will be based on this XY axis. More specifically, when we measure an angle on our coordinate plane, we will always start from the positive x-axis here. Where my red line is, we'll measure our angle from here, and if we measure it in a clockwise direction, clockwise goes this way, this would be my terminal side. This angle will be a negative angle measure, so probably about a negative 45 degrees. Whereas if I started here on my initial side, on the positive x-axis, an angle in standard position, and went this direction, or in the first quadrant to measure my angle, that angle will be a positive angle, or in this case maybe about 60 degrees. Okay, so bottom line is if we go clockwise here, let's try that again. Clockwise is going to be a negative angle, counterclockwise is going to be a positive angle. And we'll cover a little bit more of that here in just a little bit. Zipping through this next series of definitions, these are all review from geometry. Acute angles between 0 and 90. A right angle measures exactly 90. Obtuse falls between 90 and 180. Straight angles measure exactly 180. Complementary angles are two angles whose sum is 90. And supplementary are two angles whose sum is 180 degrees. Again, quick review of those terms. I'm not going to spend a lot of time on those because we should know those. Something that is new is the idea of measuring angles in minutes, degrees, and seconds, or degrees, minutes, and seconds. Just like on our clock here, this little hash mark designates minutes. So 60 minutes is the same thing as an hour, or 60 minutes is the same thing as 1 degree. Likewise, 60 seconds, our double hash here, is seconds, so 60 seconds equals 1 minute. So rather than write an angle with a decimal, like you've seen on several occasions, 60.45 degrees or something like that, we might instead have 60 degrees, say 28 minutes and 30 seconds. Just a more detailed measure of an angle. This is commonly used in the surveying field. Engineers might use our minutes and seconds to be more specific about an angle rather than use a decimal. Okay, so the bottom line is 60 minutes equals 1 degree, and 60 seconds equals 1 minute. And again, we'll look at some examples of that here very shortly. A few more blanks to fill in here. An angle in standard position has its initial side on the positive x-axis and its terminal side on one of the four quadrants. So just as I illustrated up here, my green line here is our initial side, that's the positive x-axis, and we have either of these terminal sides for our 60 or our negative 45 degree angle. That would be an angle in center position. We could have our terminal side in either of these two quadrants as well. So just a review of our quadrants: 1, 2, 3, and 4. So we have our 4 quadrants going around. So our terminal side can be in any one of the 4 quadrants. Angles with a terminal side that lie on the x or y axis are called quadrantal angles. Those angles will be our 0 degrees, our 90 degrees, 180, 270, 360, and so on. Okay, so anything that lies on top of the x or y axis, measured from standard position, is going to be called a quadrantal angle. And again, those would be 0, 90, 180, 270, 360, and so forth. Our last concept here that we need to go over is something called a coterminal angle. Coterminal angles are the same angles but with different degree measures. They're simply found by adding or subtracting 360 degrees. So what that looks like, I'm just going to slide down here a little bit and sketch in another x and y axis. And as I've already stated, our initial side is right here. If I were to sketch in an angle in the first quadrant, we're going to say that angle measured from here to here is about 45 degrees. Okay, seems fairly simple. However, if I were to measure that angle starting here, go all the way around, I've gone around 360 degrees, then back to my 45, that angle could also be a 405 degree angle. Or I could start here, go around to 360, go back around again, now I'm 720. 720 plus 45 is 765 degrees. So another coterminal angle is 765 degrees. Or I could measure that angle starting here and go in a clockwise direction. So I went down and around to here. Now that's a negative angle. That could be negative 315 degrees. So right here inside of about 30 seconds or so, we have 4 different angles, or for 4 different degree measures for the same angle. Those are called coterminal. They have an infinite number of coterminal angles, and hopefully you picked up very quickly that we simply add or subtract to 360 degrees. And we'll come back to that as part of our examples here very shortly. But before we do that, we have a handful of examples to find the complement and the supplement of. So here in number 1, it says find the complement and supplement of an angle with the given measures. Angle A is 43 degrees. We should know by now that complements are 2 angles that add to be 90 degrees, so 43 plus 47 degrees will be our complement. Our supplement are 2 angles that add to be 180, so 43 plus 137 is our supplement. Moving on to letter B very quickly, complements again add to be 90, so 85 plus 5 will be 90. Supplements add to be 180, so 85 plus 95 will be our supplement. So it's a total 180 degrees. Couple more here with that, but these are going to have minutes and seconds, so it's going to change our process, or what it looks like here a little bit, to find our complement. Long route, I would take 90 degrees, and I would subtract 10 degrees and 15 minutes from that to find my complement. That would be my second angle. Old time subtraction here. I'm going to borrow from the degrees. I took 1 degree off. That's the same thing as 60 minutes. So 89 degrees and 60 minutes is the same thing as 90 degrees. But now I have numbers I can subtract straight down. 60 minus 15 is 45 minutes. 89 minus 10 is 79 degrees. So our complement is 79 degrees and 45 minutes. I'll repeat the process for our supplement. We have supplement is 180 degrees, so 180 degrees in 0 minutes minus our 10 degrees and 15 minutes. Much like the last one, I'm going to borrow, so I'm going to knock my 180 degrees down to 179 degrees and 60 minutes. Again, same value, different form. 60 minutes is 1 degree, so I move this over here, I'd have 180 degrees. Again, just a different form so we can do our subtraction. 60 minus 15 is 45 degrees, and 179 minus 10 is 169 degrees. This should have been minutes, sorry, 45 minutes. So 169 degrees and 45 minutes. Going to repeat the process here for letter C. 68 degrees, 30 minutes, and 12 seconds. So you see we have all 3 descriptors here, degrees, minutes, and seconds. So I'm going to take 90 degrees, 0 minutes, and 0 seconds, and subtract the 68 degrees, 30 minutes, and 12 seconds to get my complement. Borrowing, I'm going to borrow twice. First borrowing is knock the 89 degree, or 90 degrees down to 89 and 60 minutes. But I'm going to take my 60 minutes and borrow from that and go to 59 minutes, which will give me 60 seconds over here. 60 seconds is 1 minute. That would put this up to 60, which would put this up to 90. Same value, different form. It allows me to subtract. I'll have 48 seconds. I'll have 29 minutes, and it looks like we'll have 21 degrees. So our complement is 21 degrees, 29 minutes, and 48 seconds. One more time here, I'm going to zip through this one. 180 degrees is our complement. We're going to subtract the 68 degrees, 30 minutes, and 12 seconds. Quick borrowing here, we'll have 179 degrees. Borrowing twice, I have 59 minutes and 60 seconds. 48 seconds, 29 minutes, and it looks like 111 degrees. So there's our complements and supplements. Again, that's a quick review. We should, I hope anyway, be pretty well versed on that, although the minutes and seconds are going to be a new concept for us. Moving on here, we have some algebra work to do. We've already discussed our complementary and supplementary. Supplementary add to be 180. Our two angles are 4x plus 10 and 6x minus 20. So 4x plus 10 plus 6x minus 20, if we add our two angles together, that sum should be 180 degrees. From here, it's simple algebra. Combining our like terms, 4x and 6x is 10x. 10 minus 20 is minus 10 equals 180. I want to solve for x. I'm going to add 10 to both sides. 10x equals 190. And if I divide both sides by 10, x is going to equal 19. Now it does tell us to find the measure of each angle. So coming back up here, I'm going to substitute 19 in for x in each of these two. So 4 times 19 plus 10. Looks like that's going to be 86 degrees. And 6 times 19, minus 20 is going to be 94 degrees. So our two angles are 86 and 94. Repeating the process here in letter B, complementary angles, I hope we all remember, had to be 90. So I have 3x plus 2x plus 15. Those are our two angles. They will add to be 90. Algebra work, combining my like terms, 3x and 2x is 5x. So 5x plus 15 equals 90. Subtract 15 from both sides. 5x equals 75. Divide by 5 and x equals 15. Finding my angles, substituting for x here and here. 3 times 15 is 45 degrees. And 2 times 15 plus 15 is also going to be 45 degrees. So both angles in this case are 45 degrees. Continuing on here, we're going to use degrees, minutes, and seconds to perform the calculations. Here we have two angles to add together. Easiest way to do this is to put this in a vertical format and then simplify once we've added together. So 51 degrees and 29 minutes plus 32 degrees and 46 minutes. I'm going to add straight down. 29 and 46 is 75 minutes. 51 and 32 is 83 degrees. However, we hopefully learned earlier there are 60 minutes equal 1 degree, so I have more than 60 here. Take those 60 minutes and make it 1 degree, so now I have 84 degrees and I have 15 minutes left over. So my simplest form for this sum is 84 degrees and 15 minutes. I'm going to change this one just a little bit. Rather than 90 minus 73 and 12, I'm going to go 73 degrees and 12 minutes minus 90 degrees just to illustrate the process here. Now we should all know if we subtract a larger absolute value from a smaller absolute value, our answer is going to be negative. So what I'm going to do is reverse this order, subtract them, and then make my answer negative. So over here to the side, I'm going to set it up as 90 degrees and 0 minutes and subtract the 73 degrees and 12 minutes. Okay, since I don't have any seconds or minutes to subtract here, I'm going to borrow. So I have 89 degrees and 60 minutes. Now I can subtract 60 minus 12 is 48 minutes. 89 minus 73 is 16 degrees. And now back to here, recalling what we talked about, because this is a smaller minus a larger, my answer should be negative. So it's a negative 16 degrees and 48 minutes. That's probably the best way to illustrate that process. Letter C is a calculator-based problem here. So I'm just going to write it out how we would type it into the calculator. We have 74 degrees. We want to convert our 8 minutes and 14 seconds over to a decimal. Well, there are 60 minutes in a degree, so 8 divided by 60 is our first decimal. We are converting this to a decimal of our overall degrees, so for our seconds, there are 3,600 or 60 times 60 seconds in a degree, so plus 14 over 3,600. And you can just type that in your calculator right as we have it written. So we have 74 plus 8 divided by 60 plus 14 divided by 3,600. And that gets us a decimal, the nearest thousand with 3 decimal places, 74.137. That would be degrees. Letter D is going the opposite direction. We're going to convert our 34.817 degrees to degrees, minutes, and seconds. So the easy part here is we have 34 degrees. Okay, that number is our whole number out here. That's not going to change. The decimal that's left is 0.817. I'm going to convert it to minutes by multiplying by 60. That gets me 49.02, which means I have 49 whole minutes. I have a decimal left on that one of 0.02, so to convert it to seconds, I would also multiply it by 60, and that would give me 1.2. Nearest second, I have 1 second. So 34 degrees, 49 minutes, and 1 second is our answer there in degrees, minutes, and seconds. Finally here, I believe we end with coterminal angles. Letter A says 908 degrees. Find the angle of least positive measure. So over here to the side, if I were to, oops, not a very good coordinate plane. If I were to catch a coordinate plane, and I went all the way around my coordinate plane, I go 90, 180, 270, 360. So my angle should fall between 0 and 360 degrees for it to be an angle of least positive measure. If you recall, with our coterminal angles, what we do is we subtract 360 degrees. So I start out here, I subtract 360. That gets me down to 548 degrees. I hope we would all agree that 548 doesn't fall between 0 and 360. So it's not a smallest angle yet, so I subtract 360 a second time, and now I get 188 degrees. Now I have my coterminal angle that falls between 0 and 360. There's my angle of least positive measure. Letter C here is a negative angle, so to make it positive, we would add 360. And if I add 360 to negative 75, I get a positive 285 degrees. That falls within our realm of 0 to 360, so here is my coterminal angle of least positive measure. And one last time here, we have negative 800, so I hope we would all agree that we're going to add, and I'm going to add 360. That's going to get me to negative 440. We all agree negative 440 is not positive, so I'm going to add 360 yet again. That gets me to negative 80. We're still negative, so I'm going to add 360 a third time, and I finally have a positive angle of 280 degrees. So there are our coterminal angles. And that covers section number 1.